Bill Oliva is Chief Structures Development, Chief of the Structures Development Section for Wisconsin Department of Transportation, Bureau of Structures.
Thank you all for coming this late in the day, and we'll try to go quick, and I'll try not to talk too long. So today what I want to hit on is our bridge preservation program and our Wisconsin asset management system. To get there, we're going to talk a little bit about our bridge preservation policy, our preventative maintenance agreement with Federal Highway and our division office. We will talk about the Wisconsin asset management system, which I'll refer to as WISAMS, scenario planning, program effectiveness, and if there's time, we'll touch on some of our structure program performance. Bridge management to us really starts with the robust inspection program and all that data that we collect for our inventory. Also, another kind of a cornerstone of it is the performance goals and the policy and strategy that we set out that we want to meet in our bridge program. Using the tools in-house, we have what we refer to as Highway Structure Information System, which is an in-house data management system that we built to maintain our inspection data. It's also web-driven and interactive with our inspectors, so they can upload information during the inspections in the field. We also developed our Wisconsin Asset Management, WISAMS, to utilize that information and use it to forecast needs. Ultimately, the goal there is recommended actions driven by data and policy. So big picture is good inspection information in projects and program needs being yielded out of that program. As I'm sure all of you know, bridge preservation really is out to maximize the useful service life of bridges in a cost-effective way. One of our goals was to identify more preservation activities to be considered along the life cycle of that bridge, just not wait until we had a replacement issue. In developing our policy, we did utilize the Federal Highway Bridge Preservation Guide, but we also undertook a study and did some elicitation of experts, both our internal experts, our bridge inspection engineers, as well as nationally. We did some outreach to many of you to talk about your concepts. But we brought all that together and put it into our bridge preservation guide. So the main goals in the preservation policy are really applying the right treatments at the right time, optimal and consistent treatments driven by conditions and time. We wanted to create preservation-specific objectives and measures and identify preservation activities, the eligibility and needs to meet those objectives. So as far as objectives and measures, in that policy, we set out a number of goals and targets that we wanted to meet. The big global ones are to maintain our bridges, our state bridges, 95% of them in good and fair condition, as well as the decks. Now, those goals that we have also go down to the paint systems and the joints and other components of the structure, but those are the big ones that we shoot for. Within the preservation policy, we have indicated activities and expected frequencies, and those are both cyclical and condition-based, and they're progressive in nature. And we've got a number of tables in there that outlines it. Also talks about the application frequency or the anticipated frequency for those activities as well. We also get into the eligibility for those activities. So in that, we've all been collecting NBI information for, quite a few years and have recently in 2015 started collecting the new element information. We have been collecting core element information for quite some time, I think more than 15 years. So our criteria are kind of a mix and match between NBI and element level. But we talk about the benefits of doing some of these actions, not just the criteria to do them, but the benefits and the application frequencies anticipated. And it goes through the super, sub, and the super deck and sub. And we also get into a number of the other components, including bearings and painted systems or painted components in there. And we do speak to the improvement to the element also anticipated from those actions. So, okay, so we've got like an understanding now of what some of these activities might be and how to identify them. To us, the proof's kind of in the pudding as far as getting them into the program. And to get them into the program, we want to make sure that they're fundable. So our next step in developing this preservation-based program was to revisit our Wisconsin DOT Federal Highway Preventative Maintenance Agreement. And I believe all the states basically have a similar document to this. So in 2016, we worked with our division office and made some updates to that agreement. The agreement now reflects the fact that we do have an operational asset management system to identify and prioritize these various work activities. We did document more work types that support preventative maintenance and preservation as being fundable with federal dollars. And we really drove home the point that we do have systematic criteria, tools, and process to implement this PM work. So some of the work types within that agreement, as you can kind of see up here, relate to the deck, various deck treatments, whether they're overlay, sealing, chloride extraction, things of that nature. Also joints, painting, spot painting, zone painting, things of that nature. Items in here dealing with the channel, the approaches, and some of the other components on the structure. So these are not meant to be exclusive, but reflective of the work types that we've agreed with our division office in Wisconsin that are eligible for funding with federal dollars. So the next way to go, so we can identify them, we've agreed on funding them, but to get them into our program, historically in Wisconsin, when we identify and program work, these were typically not typically, these were the areas that we would identify for programming bridge funds, and they're quite limited. And the other here would be kind of a catch-all for a lot of stuff. So not very granular, not very descriptive of the various types of work that we could actually do. Extracting from the preservation policy and again working with our planning people and our regional bridge maintenance engineers, we came up with a much more granular, descriptive set of work activities that we would like to program, identify with our systems, and then program into our 6-year program of work. So we've got primary work types, which is everything from thin overlays to overlays in combination with joints or bearings and things of that nature, to deck replacements, to full bridge replacements, and other major work. We've got incidental work items now, which unto themselves on an individual basis would not necessitate a project, but are really good things to identify when you are programming a project. And then our legacy items, in that we weren't going to wipe away our current 6-year program that's already in the process of being delivered. So we still had to recognize those legacy items. We also coordinated with our division office to relate our Wisconsin-defined work items with the federal highway improvement types there. So just to make sure that our financial system, which is referred to as FIPS, could talk with the federal financial system, which is FEMAS, so that we could ensure that the flow of monies could come down through our projects. And that we felt was very important to work that out. So to look a little bit closer at our Wisconsin Structure Asset Management System. So again, it's an in-house built tool that we've been working on for a number of years to determine optimal work candidates for improving conditions of structures and a whole bunch of other stuff that hopefully you can see in here as we get into it. Work candidates include rehabilitation, replacing structure elements, as well as replacing the structure entirely. And again, it relies on the historic bridge inspection data, also user-refined eligibility criteria, which began in that preservation policy but was refined in much greater detail and logic to actually become programmable work items. We import data from our highway structure information system as well as our financial system and other storage locations, that's cost deterioration data and other things. We are identifying those primary and those incidental work items based on the bridge age and condition from inspection. We can calculate the cost of doing those work items. And also we calculate a condition assessment index. And that essentially is a health index for the structure. We do deteriorate NBI values as well as some of the element values, and we did borrow some of the deterioration information on elements from BRM, so we appreciate the work of the builders of BRM. We do analysis of the work types in our program to show the benefit of doing these works in that condition assessment, as well as our ability to calculate the criticality or priority of doing those work items. So as far as identifying unconstrained needs to what you can actually program, we're able to give recommendations there. The Condition Assessment Index incorporates the deck, super sub, culvert, paint system, overlaid joints and bearings. Now this, in my opinion, is kind of the heart of the matter here, and it is the work rules. And here you just have just a snapshot of a few of them. There are about 50 work rules that we cycle through on a regular basis. You know, inspection information on our bridges is coming in daily. So it's not like once a year we've got a complete refresh of inspection information. So it's progressively and always changing, but at least 3 times a year we run the routine and identify work items and prioritize them and communicate that information to our regional offices and our central office investment management people to identify good candidates for work. So what's going on is that we're running through the complete inventory of state bridges with this logic routine and literally picking out the items that need, or the bridges that need work actions. That gets us to the point of identifying current needs, unconstrained current needs. But we're also deteriorating that information on condition and age as we go forward in time, whether it's the deck, super, and sub, and also element level deterioration. As we mentioned, we borrowed from BRM. And we also make recommendations on priority. And that is kind of a volatile place to be. It's a very easy thing to talk about in the context of just bridges alone, but truly in asset management, you're talking about your complete network of transportation. You're talking about roadways, safety, and other means of transportation also that you balance dollars amongst. But as far as criticality, you can see on the left, you know, a number of the indicators of that we can draw information in on, as well as vulnerability on the right. So those items are considered in the identification of priority, but ultimately we need to work with our regional offices that actually program the work, as well as our central office DTIM that programs some of this work. And you know, as we built this process and this mechanism and these tools, I was very concerned that when we, would come around to our regional offices with these recommendations, they'd perhaps tell us to get lost, that they had their ways of doing things. But in reality, they were very welcoming and supportive of our involvement in support and information and helping them program in a more systematic and consistent way. We provide our central office DTIM or investment management people and those regional planners a list of optimal work types, the optimal year that work should occur in, and we program in a 6-year cycle in Wisconsin. I'm sure many of you have a similar planning window. We show them the benefit to the condition assessment index. So if you do this work, what does it mean to the bridge? How does it improve that bridge and for what time? We give them information on the cost of that work and the incidental work items. That also is a priceless item. And I had the opportunity to take a break from bridges and actually work in our regional office for a number of years, managing or supervising the projects from concept through final construction. And one of the things that provided a great deal of program instability to us were the last-minute inclusion of work items. Whether it was from the financial perspective of asking for additional monies, close to the letting of the project, or the agency coordination that would be required to do painting or something of that nature at the last minute. So in identifying these incidental items early in the process during the programming side, it provides a great deal more stability and also efficiency to the delivery of the projects. So the output that we give the regions, it comes in many different formats, but this is just one tabular format of it. So we give information on the demographics of the structure, its size, all that stuff, some inventory and operating ratings, load postings, the last inspection date, but also information on its construction history, initial construction and history of other work items that were done on that structure. And also you can see the age of the structure progressing as we go down here, as well as the year. Now here we have the condition assessment index, and I don't think you all probably can see that in that it's pretty small print. But what you'll see is that condition of that structure dropping in time if no work action is done. And if the recommended work action, in this place it was replace the deck, was done, the condition assessment jumped from 34 to 60.7. And we also gave them an estimate of doing that work as being about $800,000 to replace that. So the condition is, if they do that work, the condition assessment jumps up and then it starts deteriorating down as we go through time. And then also, we're giving them the incidental work items that they should consider programming also along with that deck replacement. Additional information we give them is some acknowledgement as far as, they've actually already programmed a bridge or a project, but here they're talking about replacing the structure. And they waited a number of years, and in fact, it jumped the condition assessment up to 100%, and also to the tune of about $6.5 million. And we give them a little bit more information as far as what the project ID there also. So, here we've got a little bit difference in recommendations and application year of those recommendations. So ultimately what we're trying to do is advocate for what we would consider the most optimal work type in the optimal year. And perhaps if they elect that, they can save some money in the long run. Perhaps they could put off that complete replacement for quite a few more years. In fact, we gave them a life expectancy of that improvement in the previous screen. This is another format of the data that I don't think I'll go into with you, but it basically acknowledges our recommendations and incidental versus the region's original thoughts on programming a project. So some of the other byproducts of doing this type of analysis for one of our region offices are we're able to, since we're able to deteriorate, we establish existing needs but deteriorate through time, we can start looking at potential projects in the outer years, whether it's within the 6-year window or beyond. And obviously as you get further out in time, it becomes a little bit more sketchy information. Clearly, actual inspections and conditions trump projected deterioration. So as we get further out in time, it becomes a little bit less dependable, maybe a lot. But what's nice here is in any given year, as we progress down in time for one of our regional offices, we can start to quantify what we would anticipate as far as cost, cumulatively, or the aggregate of the complete program, or we can describe it broken out into the types of work actions, and this table goes out much farther. But I think that's kind of a useful tool for them from a planning standpoint, and also to look at maybe graphically the different work types. And this is going out to like 2050, so this is way out in time. But, whoops, let's back up. But you can start to look to see some vulnerabilities that you might have in time, and maybe the accuracy as we get way out there isn't quite right. But you're going to start to see some trends in different types of work. Whether you built large segments of highways, 30 or 50 years ago, or, some other risk factor out there, it starts to appear in there, and that's, I think, is going to be helpful from a planning standpoint, also from the standpoint of building strategies to go forward and try to mitigate some of that earlier. Certainly if you've got a whole bunch of bridge replacements, perhaps, in this out year here, you're going to start asking, can we afford to do all that work in that time frame, or do we need to take some types of actions, many years prior to that and get on top of that, or do we need to start working with our legislature to prep them, like we're going to have some big needs in 5, 10, 15, 20 years that you all need to help us find some money for. So that's kind of beneficial. Let's look a little bit at some performance measure stuff. One of our measures that we're kind of toying with is structure eligibility and program effectiveness. And what that really gets at is, we're coming up with all these recommendations and providing and working with our regional offices to program this stuff. So how much of this stuff really is taking hold? And one way to look at it is, in each of these bars represents one of our regional offices. It's like, so does the scope that we're recommending for these already programmed projects, is that reflective of our recommendations, or do they vary for some reason? So we're starting to do some analysis on that. And, most certainly there's going to be variation for a lot more reasons, or for more reasons than those that indicated the work action. For example, projects of opportunity, perhaps over a segment of roadway where they're doing a pavement replacement, it makes sense for them to do work actions on certain bridges to make sure that they can utilize the efficiency of the overall project in a specific bridge or something of that nature. So, we're trying to be smart about this and realize it's not all about our bridge data. There are other factors that come into the programming and funding of these projects. But, one of our goals might be to maximize the agreement or the consistency between our recommendations and what is actually getting programmed. Also, the timing of the projects. For a given region, perhaps, maybe about 76% of the projects are consistent as far as the scope. But how about the year that they're programming that in? And at some point in time, because of the deterioration of the project or the structure, that recommended work action may no longer be viable, whether it be a rigid overlay or something of that nature. Perhaps they let the deck go too long and now it's a deck replacement or a bridge replacement. So we're looking at measures like this to help us understand, are they able to program within the windows we need those work actions to occur? Going all the way back to our preservation policy, we had in that document a number of targets. Maintain the bridges in good and fair condition. Our goal was 95%. For our state system, we're about 96.8%. Coated steel surfaces in condition state 2 or better. Goal was 90%. We're pretty much there. One of our learning experiences was maintain expansion joints in condition state 2 or better. 90% of those? Well, on the surface, that seems like a good measure, but what if 10% of each and every one of your expansion joints is in condition state 4? All your joints are failed. So that's probably not the way to look at it. So we started toying with looking at amount of each joint in a particular condition state. That was one of our learning experiences there. And also with our bearings, we wanted 95% of the bearing states in condition state 2 or better. We're about 91.3, so we're below that, but we're not terrible there. But we can clearly see that might be an area that we want to put some emphasis. As far as our maps, MAP 21 performance measures, all of us are tracking these now. And in Wisconsin, as far as the NHS, we're hovering about 1.73 as far as deficient bridges on the NHS. And we're doing pretty good there. So that's what I basically have today. Back at Wisconsin DOT, these are a number of our engineers that have worked on this system. There's a lot of complexities to this, whether it's in the programming it and other things. So this is most certainly a multifaceted team approach, but it is yielding. It's a very homegrown, modular, as I hope you kind of took from this presentation, that we built components of this, all getting us to the point that we can make recommendations and help identify and program these activities that do support preservation of our infrastructure. And I think so far we're doing good. We know there are more sophisticated tools out there like BRM, and what we've built so far, maybe at some point in time, we're comfortable enough with the development of BRM that we port all this right over and, keep moving forward. But currently, this approach meets our needs of working with our regions. So that's pretty much all I got.
Okay, any questions? Anybody?
Just a general question. Is your system in general format out and maybe on the website, Wisconsin DOT, that it could be looked at by other states?
Our highway structure inventory system, our data management is. And all of you can get access to it, and you can run reports and examine that. And it's a really nice system. It's web-based. So that's what our inspectors are using, and people can query information on individual bridges. You can call up the bridge plans and all of the inventory data associated with the bridge.
Is your WISAM system a spreadsheet-based program, or is it a higher language? And if it is a higher language, how did you find engineers that can do that?
That is the $100,000 question right there. And no, it is not spreadsheet. It's database. And we do have an engineer that is a programmer and highly experienced. And this is an area that I do not have a lot of experience with. My boss, Scott Becker, the director of our Bureau of Structures, is a programmer, and he in fact was the originator of Highway Structure Information System, and I give him tremendous credit for that. And at this point you find these individuals and you give them the freedom and the support to create, and that's what we've done there.
Do you try to align your work, bridge work, with your pavement work? Is that any correlation between them, or do you do separate work?
And that, as we looked earlier at some of the, variation of why we might not be matching up, that would be one of the drivers. In all honesty, a lot of the bridge work in our state, and most likely in your states also, is being driven by, opportunity when they're having the pavement projects, the larger. Not all of it, obviously. There's a lot of standalone bridge projects, but often the pavement projects do bring the bridges along with them for programming purposes. But what's kind of nice about this also is, as we've been developing asset management and the transportation asset management plan and working with the programmers, it's not bridge programmers, but project programmers, they're liking this an awful lot, and they're very much welcoming us to help them in a more data-driven approach to programming the overall assets, whether bridge or pavement, or safety is a little bit of a different beast.
Thank you, Bill.
Thank you.
Very good presentation.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.